Today we're going to look at the Arduino. We're going to hook up 7 LEDs and I'm going to show you how to do Knightrider code on it. Then I'm going to show you how to do some improvements on the Knightrider code using a for loop. So let's just take a look at the pinout first. Actually, before I continue, I'm using this website 123dcircuits.io. It's pretty cool. You can actually wire up the breadboard, the Arduino. You can write your code the same as you would on the Arduino IDE or the Inertia, and when you upload and run, then the code actually runs on this simulation on the website and you stop it. Pretty cool. This is just going to be easier for me to do some coding and illustrations. Let's just take a quick look at the breadboard and the Arduino. I just have the ground going to the ground rail, jumping the ground rail across the board to make the LEDs a little cleaner. The LEDs are the red, brown, which is 220s. So from each pin, I'm using pins 7, 8, 9, 10, 11, and 12. Your pins may differ. Then I'm coming out of the pin into the positive leg of the LED. Then the negative leg of the LED will go to the resistor. Then the other side of the resistor will jump the trough of the breadboard, and then it'll come over here to ground. And then the complete circuit will be had when the ground comes back into the Arduino. And that's the same for all the pins then. So we have 7 LEDs. So let's take a look at the code so far. Remember, we have a setup. The setup happens once when we run. It's usually to initialize pins and also maybe any variables. And then we have the loop. The loop just continues to run as long as there's power to the Arduino. What we have to do in the setup is we have to tell all the pins that we want to use, which in my case is 7, 8, 9, 10, 11, 12, 13. And we want to use them as outputs, not inputs. So 7, 8, 9, 10, 11, 12, 13 as outputs. And then right now I have incomplete code for the Knightrider, but all it's going to do right now is it will turn 13 on and all the rest off. It'll delay for half a second. It'll turn all of the pins off, but 12 on, delay for half a second. Then it will turn all the pins off except for 11 on and delay for half a second, and then it'll just repeat. So we will see 13 on, delay, 12 on, delay, 11 on, delay, and then repeat. So 13, 12, 11, repeat, 13, 12, 11, repeat. So once again, let's just see that in action. Okay, so I'll hit start simulation. So we see 13, 12, 11, 13, 12, 11. Okay, so I want to do some improvements to this code. Well, first of all, it's not a complete Knightrider code, and I guess we can do that really quickly if you wanted to. My trick there is copy this hunk, paste it underneath, make them all low, and actually then I just copy and paste this for as many. This is like a template. This is there's definitely other ways of doing it, but if you're just starting out, this is I think the easiest way to understand, because you're setting all the pins at once. So we need to do this for 11. And then 10, so 4 more times. Well, wait, this will be 10, so 3 more times. So 1, 2, 3. And now what we can do is just paste high where we want it, so you can actually visualize it in the code. So 13 on, 12 on, 11 on, 10 on, 9 on, 8 on, and 7 on. And then it will just repeat. So it's not a true Knightrider. It's not going back and forth right now, but it'll you could easily kind of continue with that pattern and have then it go back up. So then 8 would go on, 9, 10, 11, 12, 13, or actually leave 13 off, because when it repeats, 13 will be the first one. So don't have it come back to 13. Otherwise the 13 will be on like for twice as long, and that kind of looks weird. So let's upload and run. We can see this code running, and now we have all of the LEDs. Okay, so there's the basic Knightrider, but let's talk about some improvements. So the main reason I wanted to do this tutorial was to introduce a for loop. So there's two different kinds, well there's really three, I guess, kind of loops that we use. We have a for loop, a while loop, and a do until loop. So right now let's just talk about the for loop. The for loop is used when usually when we know how many times we want to loop something, and especially if we have numbers in order that we want to loop through. And a good example of this, if we ever see code like this, where the only thing that differs between these lines of code is the number 7, 8, 9, 10, 11, 12, 13, then that's a great example where you would want to use a for loop. So the way that we're going to replace all of this code here with a single for loop, and I'm going to explain the syntax of the for loop. So the way a for loop works is you use the keyword for, and then you have parameters on the for loop, and in there you need three things. Okay, so those three things are a starting condition. Now we need some kind of variable, so we say int, and I'm just going to call it pin, because that's what it's going to represent. The pin's going to start at 7. Okay, so that's what that means. It means when we start this for loop, the pin variable is going to start at the value 7. Okay, the second parameter is when do we want this for loop to, under what circumstance we want this for loop to keep running. And that would be as long as pin is less than or equal to 13. Then keep this for loop running. So you can think of it about this as like, as long as this is true, keep this for loop running. As soon as this becomes false, the for loop ends, and it will not run again until the code is executed again, if it's in some kind of a loop. The third parameter here to the for loop is how much we want pin to increment each time we loop. And right now we want it to go 7, 8, 9, 10, 11, 12, 13, so that's just by 1. And there is a shorthand in C, C++, Java, which is pin++. What that means is, that means increase pin by 1. It's the same as doing pin equals pin plus 1. But it's quicker just to do pin++. Okay, now everything we want to loop, we have to put inside these brackets. And so what this is going to do is then pin will start at 7, this pin variable. It will keep going as long as pin is less than or equal to 13, and we will increase pin by 1 every time that we finish this complete loop. And inside this loop, well, what do we want to do? We want to set the pin mode of pin to be an output. And so what we've just successfully done is we've replaced all of that code with a single for loop. And essentially it's going to be exactly the same as the code that I just had laid out, but it's going to be in a nice, neat for loop. And this is less code for sure, and it also just makes things, you know, nice and neat. If I ever needed to change the pins, lower, increase it, I can do that quite easily as well. So you're going to see, let's upload and run this, nothing's changed in the code. Okay, so we have the exact same functionality. All those pins 7 to 13 are set as output, just one at a time using a for loop. Okay, so there's something else we can do. So you'll probably notice this is a fair amount of code just to have those LEDs go across. And we don't even have them coming back. So if we wanted them coming back, we'd have to pretty much duplicate all this and just reverse the order. Now the problem with doing this is it's a lot of code, and the Arduino Launchpad, it only has so much memory for our code, and if we keep doing this kind of thing, we actually run out of space when we try and upload the code. There's a couple ways we can make this code shorter. We definitely don't have to keep turning pins off if they were already off. That's one way. So you'll notice, like for example here, pins 7, 8, 9, 10, 11 are already off. We don't have to tell them to be off again, so we could kind of get rid of some code. Now, that would help, but I'm going to show you an even better way of doing this using a for loop. So if we take a look at, let's just take a look at the pattern of what this code's doing. This code is saying that we want all the pins to be off except for pin 13. And then we just have exactly the same code, and we say all the pins are off except for 12. All the pins are off except for 11. Now, whenever you see a pattern like that where we're kind of counting through things, we should be thinking about using some kind of for loop, if we could do that. And we can. And I'm actually going to reverse it though. Instead of going 13, 12, 11, so go counting down, I'm going to start my for loop counting up just like we did here. It just makes it a little easier. We could easily count it down, and I will show you that after we count up. So let's again have the same kind of for loop, for, and in the for we have to declare the variable. That's why we have to put the word int there. This time I'm going to say high pin, and we use camel case for the variable name, so it's two words, high and pin. So we capitalize the word pin, but we always lowercase variables. The first letter is always lowercase. So high pin, let's start it at 7. We want to keep going as long as high pin is less than or equal to 13. And we want high pin to go up by 1 each time. And what would we like to do? Well, essentially what we want to do is we want to turn high pin on. Now, what's the condition here? We can't just do this because all of the other pins, whatever state they were in, high or low, will continue to be in that state. So if I just turn the 1 on, this isn't going to be complete, and what this will actually do is just turn them all on really, really quick, and then they'll just look like they're all on, and then it'll execute this code. So maybe what we could do is we could actually just turn them all off right here above the loop. And yes, we could use a for loop for this too, definitely. Maybe we should use a for loop for it. Yes, we should. Okay, so I just want to start all the pins off being low. And I think I'm going to rename this pin again, because it's not the high pin. Okay, so we go through all the pins really quick. We don't delay, we just turn them all off. Now we know the state of all of them. So the idea will be, while I go across here, if they're all off, and remember I'm starting at 7 this time, if they're all off, I want to turn 7 on, and then I want to delay. And then we turn 7 off, go to the next pin. Turn 8 on, delay. Then turn 8 off, go to 9. Turn 9 on, delay. Turn 9 off, go to 10, and repeat. And we can do this really, really easily using the for loop. So all the pins are off. We turn 7 on, right? We put our delay in there. And then we turn 7 off. And then the for loop automatically, because we've done the complete for loop, when we come back around, high pin was 7, now it will be 8. and then we turn 8 on, we delay, then we turn 8 off. And then we repeat again. Then we turn 9 on, we delay, and then we turn 9 off. Now, there's no delay from, say we start with 7, pin 7. When we turn pin 7 on and we delay, then we turn pin 7 off. When we come back with the for loop and we turn pin, and now high pin goes to 8, and we turn pin 8 on, there's really no delay. There is no delay from the time we turn 7 off to the time we turn 8 on. So you don't see any kind of like flicker. There's no better way of doing that, really, because in order for us to see something, we really have to delay, you know, a fair amount of time. If it's, so we have to put something like, I don't know, like 50 milliseconds or more. So 500 is, you know, it's a big delay. But what I'm getting at is the time it takes to turn 7 off, then hit the for loop at the top, then make high pin 8, and then turn high pin, then turn 8 on. There's no pause in there, so we don't see any kind of flicker. So let's get rid of all this other code, and let's test out our code. So you see this is a lot less code, which is good when we're uploading. It gives us a lot more you know, space for other code. We should probably add a comment here, a couple comments. Turn all the LEDs off to start. Okay, and then turn each LED on one at a time from 7 to 13. Alright, so let's check out our code. So we should see them all, well, they all go off instantaneously. We don't have a pause there. And then we should see 7 on, 8 on, you know, 7 on, then off, 8 on, then off, then 9 on, and so on. Upload and run. Okay, there you go. And we don't have it coming back, we only have it going one way. So now we have a Knightrider code using a for loop. But again, this isn't a Knightrider code, but in order to have it come back, we could do that really, really easily now that we know for loops. One trick here is a lot of people, they say, okay, I went from 7 to 13. Now I kind of want to reverse this and go from 13 to 7. And they do like kind of the exact same code from 13 to 7. The problem with that is 13 and 7 stay on twice as long and it doesn't look very good. So if we take this for loop, there is something we have to do here, because we want to go now from 13 down to 7, and we have to say, well, start at 13 as long as the high pin is greater than, so you have to switch that to greater than or equals 7. And now we want, instead of going up, because if the high pin went up, it would go 13, 14, 15, and we don't even have those pins, first of all. And this would always be true, so we would catch ourselves in an infinite loop. So we need the high pin to go down, and there is a short form cut for that. It's high pin minus minus. We would say turn each LED on one at a time from 13 to 7, for example. But there is a bug in this code, and that is we are going to stay on 7 and 13 twice as long. The reason that is because we're turning, so we start with 7 on, 8, 9, 10, 11, 12, 13 is on, then we turn 13 off, and then we hit this second for loop that says, okay, start at 13. So we turn 13 on again, then delay. So 13's just stayed on for twice as long. And then also when we come down to 7, we turn 7 on, delay, turn 7 off. But then when we come all the way back around, actually we turn them all off, and then we turn 7 on again. So let's see that, because this is a very common mistake that people make. And if we upload and run this, watch for it at the ends. It'll stay on twice as long. Alright. Now to fix that, what we want to do is when we're coming back, we say, okay, well, we just did For example, when we're done with this for loop, we just did 13, so we actually want to start with 12. And because when we're done with this for loop, we're about to turn on 7, we actually want to only go to 8 here. So we want to say go from 12 to 8. What I'm letting this one, we only need 7 and 13 on once here in this whole procedure. I'm letting this for loop turn 7 and 13 on, and this for loop will only do the middle ones so that the outer ones don't stay on twice. So now let's take a look at the code again. And so that looks correct now. Okay, so we have a complete Knightrider now, with not very much code at all. We have 4 for loops, right? For loop to turn all the pins, a for loop to turn off all the pins, just so that we know the state of them before we start turning them on, pausing and then turning them off. Now, one other improvement we could do with this is we could speed up the code a little. That's what I think I'll do in the next video. So we'll stop this one here.